Hello, my name is Jay Sharma. I'm a student at the University of Maryland College Park and I'm pursuing my master's in robotics. Today, I want to talk about a project I've been working on over the last 16 weeks. It is part of a course called ENPM809T Autonomous Robots. The course was designed and taught by Dr. Stephen Mitchell. So the goal of the course is to build an autonomous ground vehicle which can accomplish a given task by the end of 16 weeks. We call it the final challenge and it is done at the end of the semester. So the vehicle I've built is right here. I call it Atlas. It's run using a Raspberry Pi. We have a Pi cam facing the gripper and we have a sonar sensor also used for obstacle detection. It's run using 4 motors. The front, left, and the right back motor also have an encoder attached. There's also an IMU which I've placed towards the center and bottom of the chassis. So now I would like to go over the final challenge we had for the semester. So we were given a 12-foot by 12-foot arena where there are 2 important locations. One is the landing zone where the robot is placed initially, and then we have the construction zone. So the environment is quite cluttered. It has a bunch of RGB blocks, red, green, blue. The goal of the robot is to, one by one in the sequence of RGB, go pick up the block and return back to the construction zone. So to look more closely into the requirements of the final challenge, I've made a mind map. The main 2 functionalities are localization and perception. For perception, we need to detect the blocks using HSV masking. We also need to make sure there's a collision avoidance system so that our vehicle does not go and hit a wall. And for localization, the vehicle needs to know where it is on the map at any given point so it can find its way back to the home position. Other than these 2, we also have other functions like running a gripper for picking up the block. We have a PID loop for the motors, and we have a functionality to send emails. So via the course and the assignments we do, we get a chance to study these individual aspects of an autonomous system, and here's a snippet of my journey. The perception stack was working quite well. I was able to tune my HSV mask upper and lower limits so it can detect the red, green, and blue blocks. And I also added a function that would help my vehicle align with the direction of the block. And I was always recording the yaw angle change so that my localization was not lost at any point. I performed localization using encoder data and IMU data. The encoder ticks would give me an estimate of how much my vehicle has moved ahead, and the IMU could give me the yaw angle at any given point. So I would collect this information at the home position and at a point where my gripper has picked up the block. So I would compare the pose in the 2 points and make the required correction. The localization technique was working quite well in the days leading up to the final challenge. I was able to get about 4 or 5 blocks back into the construction site. However, after that, the error in localization becomes too high and the robot starts making mistakes in judgment. The final challenge did not go as well as I would have liked. My vehicle was able to successfully pick up 5 blocks. It meant that the perception stack was working fine. However, localization errors got worse over time, and the vehicle would not bring the block back to the right place. As expected, the Raspberry Pi sent out an email each time a block was picked up. And I was also happy that my vehicle was able to enable the exploration function. It was a prevention I had said in situations where a block is not in the field of view, so the vehicle will have to go ahead and explore the area in search of the block. However, after 5 minutes and picking up 5 blocks, and as a result of the errors in localization, my vehicle collided with a wall and that had to end my run. There was an error in the post correction which would get my vehicle back to the home base, and it was overestimating the angle change. I was able to spot it quickly and fix it after the challenge. However, the bigger issue lies in the robustness of the localization logic. After exploring enough, the error becomes too high and eventually my vehicle will be lost on the map. So to fix this, I needed to calibrate itself when it comes back to the home base. A way of doing this would be to use the sonar sensor and take distance readings from the 2 walls in the corner. This could give me a very reliable position of the vehicle on the map, and I could update the home position accordingly. I definitely plan on correcting the localization and working on this over the summer and making it even better. I want to thank Dr. Stephen Mitchell for his support over the last 16 weeks, and it's been a great journey being part of ENPM809T Autonomous Robots. So thank you for tuning in and hope you enjoyed this video.